What's up, everybody? I'm Jason. Welcome back to the vlog. And yeah, I know, last week when I did the vlog, I talked about how I was going to be doing virtual production on the vlog with a green screen and a virtual set and all of that. And this week, I'm back here on black background talking to you. The reason for that is that I'm doing something, again, completely different. I had in mind an experiment. Turns out that it was intended to be an experiment in a number of directions, actually. So let me give you a little bit of background and we'll jump in and we'll actually get through this. Hopefully this time, now that it seems like I actually have everything running properly. So I've been looking to do a little bit more talking about lenses. I don't want to call them lens reviews because I don't really think that they're reviews per se. I don't know quite what to call them yet. Discussions, looks at, I don't have a good term for it, but some of this is testing. So there is a review component, or at least a testing component to what I want to do. And one of the tests that I'm interested in doing is a test looking at breathing. So I want to see how much the field of view changes due to the lens breathing. And so consequently, you can do this, of course, manually. Focus at infinity, measures the field of view, focus at minimum focus distance, measure the field of view. I did that. I tried it. It's a real pain in the butt. It's not very ideal. So I decided that I was going to write some software to allow me to feed in two images that would have two test patches on it, or target patches on it, and the software would find the center of those target patches and then calculate the distance between the centers and then calculate how much the targets moved from test to test. I'm doing this in percentages. It doesn't need to be like pixel accurate or anything like that. It just needs to be good enough to be able to give me a good idea, a reasonable idea of what I'm looking at. So that's what we're going to be looking at today. We're actually going to be looking at me writing the software, and I'm going to talk about a little bit what I'm doing, and I'm going to talk about lens reviews and testing and some thoughts going on about that. So let's get the review started and, get into this. It's obviously playing back really fast. I'm not this fast on a computer. I'm playing this back at 4 times speed so that the hour and 10 minutes or so that this actually took gets done really fast. So the first couple of minutes here is just setup, getting project directory set up, getting Git set up. I version control everything. It's like the ultimate in undo if you use it at least. And I'm now doing some boilerplate Python code. So the scripts are written in Python. I'm using OpenCV, the computer vision library, to do the processing because it's really easy to deal with and good at that. And at this point right now, I'm setting up argparse, which is an argument parser. It's the thing that takes the little bits that you put after the file name. So like in this case, I've got 2 arguments that I supply to the program or the script. It's file 1 and file 2. And that's it. The 2 files to compare. And I could do this a lot simpler in theory, but the advantage of doing this with argparse is if down the road I need to start adding adjustments for, say, changing threshold values to deal with real-world images, I can do that. I'm also creating here in Photoshop a test image. So this is roughly reflective of what the actual image would look like. 2 white rectangles on a black background. It's 2 white pieces of gaffer tape on a black background, essentially. The reason I'm doing this in Photoshop first is that I can create a perfectly clean image. No noise. The only 2 pixel levels are black and white, so it's easy to separate and deal with. And it's like the strategy here, whether it's programming, whether it's learning a new skill, or doing something in cinematography or production or whatever, the strategy that I use at least is start simple and build on it. So it's, you know, you'll see this through the whole process looking at the way I'm writing the code. It's, so can I load the images? Okay, load the images. Can I identify the target areas? Okay, I can do that. Can I find their centers? Good, got that. Okay, can I load the second image and do the same thing? And good, okay, that's done. Okay, can I calculate the distances or then calculate the distances? Okay, fine, that's all of that. And then ultimately, I'm gonna add RAW support to this because I shoot in RAW and I don't wanna have to reconfigure my camera to JPEG every time I go to use the program. Of course, bugs, screw-ups, all that stuff, it's par for the course. As I said, I'm not a professional programmer. I do not spend every day in Python or this environment. I've only been using OpenCV and doing this kind of image processing now for like 4 or 5 months. So this is all relatively new to me. And again, not doing it every day means it's a process that I'm just, you know, I still have to look stuff up in the documentation. It's all, you know, all very new, you could say, in a lot of cases. It's not the, you know, like, I'm not an old hat at this. So I do make occasional mistakes. I did run into a bug here. If you happen to be a Python user and you happen to be using OpenCV on Python 3.10 point whatever on Ubuntu, and you get an exception just from including OpenCV in your Python script, check your NumPy version. Mine was out of date and not compatible, at least, with the version of OpenCV that I have installed on my machine. I didn't find anything on the web. You know, I saw lots of things about change OpenCV to do this or that or the next thing, but it turned out all I needed to do was upgrade NumPy, and that would take care of it. So while I flounder at this, let's talk a little bit. Let me talk a little bit about lens reviews. I'm open to some suggestions. So leave a comment what you find useful or important in a lens review to give me some feedback. Because my feeling on the matter is most people seem to find the most important things in their lens reviews or in a lens review is like resolution and straight image quality. And for me, that's always a challenging place to kind of deal with or work on for a couple of reasons. First of all is I only have one lens. And the simple reality of optical design is, and lenses being a manufactured product, is there's far more variability in the lens design or in a lens from copy to copy due to manufacturing differences than there is in something like, say, the sensor in your camera. You can test a camera and have a very good idea about how that camera is going to perform optically or for dynamic range or whatever. Testing one lens doesn't give you the total picture. My go-to recommendation if you are looking for lens reviews is to look at the Lens Rentals blog. They have fleets of lenses, 10 or 20 lenses per model, and they use image quality, resolution, etc. as an indicator of whether the lens needs to be repaired or not. And so they've got what I would consider statistically relevant information when it comes to lens design. You know, how much, how good, how you know, how all of this stuff performs compared to just, say, you know, a guy like me taking the one lens that I bought and measuring its resolution and then saying, well, it's a really sharp lens or it's not a really sharp lens, because I don't really know. One sample is not really relevant when it, or statistically relevant when push comes to shove. So as much as I want to include stuff like that, I also run into the problem of where or what do I, how do I approach that? How do I deal with that? Because, like I said, if I'm only have one lens and I know that that's not going to be significantly or statistically relevant, yeah, I could add that one piece of data to the body of knowledge that we all have, and then I could, you could look at many reviews and make an estimation based on that. But again, I'm not sure it's really a good use of time, money, and effort to kind of go into that in that much detail to, try to make something comparative. And then, of course, there's my test setup error, the next guy's test setup error. It's kind of a mess, which is the biggest reason that I've largely sort of stayed away from doing lens reviews, because it's hard. And of course, if it was easy, everybody would do it and nobody would care. But I also found that in at least recent times, I've become less overtly dependent on how good a lens is resolution-wise. For me, there's bigger factors at play in what I'm going to buy. So if I'm talking about something like Canon's 28-70 f2, well, it's the only general purpose f2 zoom on the market. There's no, this isn't I could look at somebody else's X or somebody else's Y or somebody else's Z that's comparable. There's nothing out there that's comparable to that. So how important does those exact technical details need to be or end up being? I mean, in the case of the 28-70, it doesn't have any obvious defects like focus shift problems or things like that. So knowing that it exactly resolves N lines per picture height or whatever doesn't seem all that material to me. So that's the open discussion part of things. So leave a comment. Let me know what you find most interesting, and I will see how all of that kind of plays out. So jumping back over to what I'm doing, because we're almost 40 minutes in, and I am getting close, I think, to the point where I'm going to be actually testing this with real information, real images. In fact, that looks like what I'm doing right now. I'm either reading documentation on my other monitor, because I do have two monitors, or I'm shooting test images, and we'll find out in a second when the thing comes back. So this whole process in this script has been an iterative thing. Make something work, build upon that. So what are we doing? Yeah, okay. So we have now got two actual test images. These were shot on a gray background instead of a white or black background, so they're not quite right. And obviously the thresholds that I set up when I was working with pure synthetically generated images, they're not going to be quite right either. In fact, now I'm doing a second set that I believe are underexposed 2 stops so that the gray is closer to black and the white is still fairly bright. And this is going to be a matter of stepping through and looking at what the software comes up with, and then looking at how to adjust the thresholds and whatnot to figure out where this actually needs to be. So again, this is a real kind of iterative sort of process, and first thing we see is those extra spots that are outside of the gray rectangles, the light rectangles. There's they're centers or targets that are not what I was actually intending. So again, it's going to be start to play with the Gaussian blur, which helps to smooth out information. It's going to be to start looking at threshold levels and how the software calculates thresholds. And, all of a sudden here we're looking at getting close. You know, we're about 50 minutes in, and we are, I think, yeah, I've got it working at this point for JPEGs. So for the next 20 minutes of actual time, which is going to be about 2.5 minutes of, or 5 minutes or whatever it is, of video time, it's now implementing RAW. So why implement RAW in this? Well, because I shoot RAW, and I don't want to have to reconfigure my camera and then forget to not unconfigure it when I'm done shooting this stuff. So it becomes a matter of, I want this to work on RAW files because it's the intelligent, it's the easier thing to do in some respects. And I make a bunch of pretty good gaffes in this process. Like, again, not a professional programmer. So you'll notice I'm looking for CR2 files, except my camera shoots CR3 files, so it's never going to find the RAW files. Ultimately, I end up refactoring this entire structure right here to basically try loading the file with OpenCV. That handles all like JPEGs, etc. If that works, then I don't have to worry about it. I have the data. If it doesn't work, try opening it in RawPy. If that works, great, I have the data. If it doesn't work, then just crash. This is a big difference too. So part of what I wanted to kind of explore in this video and talking about this is the, call it, difficulty of writing software, and specifically how long it actually takes. I know some of my audience is professional programmers or computer engineers, software engineers. They do this stuff all the time, and they're probably laughing at me for being as slow and awkward and crap as I am. The other part of the audience I know, though, is not. And I find a lot of times non-computer people will say, why can't company X just do this? It's so easy. It should be so easy. They've got engineers and everything. And, you know, here's a sort of a bad example, but sort of a good example. This is a pretty simple implementation. Find two shapes, find the center of the shapes, and calculate the distance between the centers. And we're an hour in of, I'm an hour in of actual programming time on this, and I've got it working for JPEGs, at least in most cases or some cases. Now I'm trying to get it to work for RAWs. And should it have taken an hour? Or an hour and 10 minutes is what it ultimately ends up taking, as I, again, realize how some of the stuff I have to do for post-processing. Yeah, I'm not 100% familiar. This is the first time I've ever used RawPy, so I'm not 100% familiar with the command options and how to go about doing stuff, which is why I'm, you know, going through documentation left, right, and center, or at least on the right side of the screen, to find this stuff. But this is also really easy, and this is also basically a minimum viable product. So this is good enough for me to test something. If I was going to distribute this to people through GitHub or, you know, whatever, so that anybody else could use this, I'd have to make this a lot more robust. But if this crashes on me, I don't care. I can fix it. It's not software running on a camera, so crashing is fine. It doesn't ruin my day. It's not going to end a photo shoot or something like that. There's an entire level of complexity in terms of error checking, properly handling situations, properly dealing with basically everything that comes with writing code that's going to, say, be running on an embedded system that I won't say can't fail, but shouldn't fail. Like, your camera shouldn't just crap out in the middle of the day because the light was the wrong, you know, was a certain color temperature or something like that. Whereas this, I'm not worried about any of that. I don't care. There's no documentation. Certainly, while we're not getting access to all of the documentation for every function in Canon's cameras or Nikon's cameras or anybody else's cameras, the people internally are writing documentation because another engineer is going to have to come along and either use the function that they're writing, or they're going to have to fix it or implement something else, or, you know, whatever. And then compounding on top of that is that I, like I said, can get away with this just being overly simplistic. Is, I guess, ultimately what it comes down to. So here at an hour and 10 minutes of actual sitting there programming time, I've written this function, and it can compare two images that are shot in RAW off a test target with, you know, reasonable level of competency for at least a very small number of tests. Now imagine the complexity, how the complexity goes up when you're writing this in a language that doesn't take care of a lot of this stuff for you. Python's a scripting language. It's incredibly easy to learn. It's incredibly easy to deal with, and it takes care of almost all of the dirty little details of writing, of memory management, of all of that stuff. But you don't write Python code to run on an embedded system in a camera in a time-sensitive environment. That's going to be C or C++. It's going to be written, it's a much more complicated language to learn. It's a much more complicated process to work with. And the overall, what's being done is much more complicated. And of course, there's much more stringent test requirements that are being done. Like, again, with this, I don't care if it doesn't quite work. I've got, you know, I can just fix it. You know, it's not gonna cost somebody time or money or you know, something like that, because my script here crapped out in the middle of them shooting a once in a lifetime, or, you know, a single shot multi-million-dollar Hollywood effects thing. If it craps out on me testing a lens, I can take a couple minutes and fix it and go back to testing the lens, and it's not going to end the world. The level of complexity is completely different here. And still, this was over an hour of time in a language I'm familiar with some libraries that I'm not 100% familiar with. This could easily, you know, you ramp up the difficulty and this easily rolls into 2, 3, 4 hours, and then as much time in testing, and then as much time in, you know, a whole lot of things. And again, you know, we're talking, this was a very simplistic case here. And an excuse to, like I said, I wanted to see how long it would take. I was also kind of booking on this faster than I normally would. And I thought it would be interesting to sort of share the behind the process a little bit, and talk about lens reviews, which is something that I wanted to solicit some feedback with. So I'm going to wrap this one up here. If you found this interesting, I hope you did. If you did, let me know by hitting that like button. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you're not already. Also, if you'd like to support this channel and content like this, or any of the other technical content that I produce on Canon cameras or photography, videography, etc., please click that thanks button if you can. Every little bit does help. And in any event, as always, thanks for watching, and I'll see you next time.